Today we're gonna continue the lesson from where we left off last lesson, which was at the end of 3.2. So have 3.2 notes out so you can finish it up at the bottom. And I gave you the 3.3 notes last class, so have that out. So we're gonna go through a few things, okay? This is not on your notes, so can you go ahead and pause this video and draw this and do this table. And over here, write sine of theta. Just copy it down. Pause the video if you need to. There we go. Alright, so we're going to go ahead and redefine the sixth trigonometry ratio. So, alright, so I talked about the unit circle earlier, last video, and you're like, well, when are we going to ever use this? Like, what is this for? So that's where this comes in. I'm going to show you how we're going to use the unit circle. Okay? Alright. So there are all my trig ratios, sine of theta, sine of angle, cosine of angle, and so on. Right triangle definition is all the SOHCAHTOA. That's what we've been doing, right? So sine is what? So, opposite over hypotenuse, ka. Adjacent over if I were you, I'll pause it and see whether you remember, because that's like the most basic. Towa. Opposite over adjacent. You read it cosecant, that's a reciprocal of sine. Secant is a reciprocal of cosine. Cotangent is a reciprocal of tangent, so adjacent over opposite. Yay? Alright, so that's how we've been doing on the right triangle. Now, what is this circle called? I know it's very lopsided. Don't look at this. Oh, excuse me. Look at this one. I'm sorry. That is a unit circle. Why is that unit circle? Because it's a radius of 1, center at the 0. Hypotenuse value is a 1, so this is your hypotenuse, and in relation to angle theta, your adjacent side is a x, your opposite side of angle theta is a y. So, using this unit circle, I'm going to just plug it in. Ready? Alright, so sine of theta is opposite over hypotenuse. What's the length of the opposite side? Y over. What's the length of the hypotenuse side? Alright, usually what we will do, we're just going to say y over r. However, since this is a unit circle, we're going to say y over 1. Our value is going to be 1. That makes it just a y. So guess what? Sine of theta is the y value on the unit circle. We'll get to what that means in a second. Cosine of theta is adjacent over hypotenuse. Adjacent is x over hypotenuse is the r value, but it's a unit circle. R is 1, radius is a 1. Well, I can't, guys. I'm sick today. That's x there. Tangent opposite side, y over adjacent side, x, y over x. Cosecant, here's what I'm going to do. I'm going to just take the sine value and just reciprocal, right? So reciprocal of y is 1 over y. Reciprocal of secant, secant is a reciprocal cosine. Cotangent is x over y. You know, in class I talk about the Quizlet. Alright, there we go, another Quizlet right here. I need you to memorize. I don't need any pens. You gotta memorize it. How? So when I say sine of theta, you should know that's the y value of the unit circle. Cosine of theta, x by tangent, y over x, cosecant, 1 over y, secant, 1 over x, cotangent, x over y. Honestly, the bottom 3 row, you're not really memorizing it. Because as long as you know cosecant is a reciprocal of sine, you know sine is a y, it's going to be 1 over y. Okay? Please memorize this. Okay? Alright. So now go to 3.3 notes. I might sneeze a lot, so I'll just go stop. Before we can identify all the coordinates of the unit circle, we need to investigate the sign of each function as we move around the circle. Okay. Actually, let's not do that. Let's go back to our unit circle. And I'm going to explain how to use it. Okay? Or how to find what I'm looking for. Capiche? Alright, first thing first. We're going to learn how to memorize the first quadrant. The first quadrant. You know what? It's easier if I use that. First quadrant. How? Well, let's review. These 3 angles are the ones from the special triangle, right? 30 degree is 30 goes in 6 of them, and one's 80, so pi over 6. 45 degree, how many 45 goes in 180? 4 of them, so pi over 4. And 60 degree goes in 183 times, so pi over 3. So those are angles in radian. Now, here's how it's going to work. to fill out the first quadrant, folks, all of them are going to have a denominator of 2. You can do that, right? In fact, what I'm explaining is like over here. Now, do you see there are 3 things going on? Like, think about those 3 angles as those 3 fingers in the middle. And please use the left hand. I repeat, left hand. Okay, and here's how it's going to work. For pi over 6, that's the very first angle in the first quadrant. You're going to, and if those 3 matches with those 3, put that pinky, what is that one? Ring finger down. Then how many fingers do you have left? You have 3 and 1. And that's going to go in the numerator like that. So for pi over 6, it goes 3 and 2. Alright, what about pi over 4? That'll be the middle finger. How many fingers do you have on the left side? 2. How many fingers do you have on the right side? 2. So 2, 2. We're not done, by the way. Alright, pi over 3, your index finger goes on. You have 1 and 3. This is called a finger trick. Now all you have to do is put the square root on the numerator. Does 1 need a square root though? No. So just put that over 3, put that over 2, and put that over 3. That's how you memorize the first quadrant. Okay? One more time. One more time. Alright. Pi over 4, it's going to be square root of 3 over 2, comma, half. Pi over 4, square root of 2 over 2, comma, square root of 2 over 2. Pi over 3, half, comma, square root of 3 over 2. Yeah? It's a finger trick. Now, you have to know which angle goes in what quadrant. Alright, 2 cases. All these corners are easy peasy. We know that. Corners, our favorite. 0, 2 pi, 1, comma 0, pi over 2, 0, comma 1, because the radius is the 1, right? That's a straight line is a pi, negative 1, comma 0, that's a pi, 3 pi over 2, 0, comma negative 1. Easy peasy, corners done. You couldn't even see it. Now, remember, you were like kind of taking one thing at a time and reflect it over. So for example, and I'm going back and forth a lot, like this orange line here, had a reference angle of pi over 6. So when I flip it over along the y-axis, it was 5, 6 of pi, along. So these 4 orange are like team. They all have the same reference angle, pi over 6. These greens, you can't see, are the same, pi over 4, 3/4 of pi, 5/4 of pi, 7/4 of pi. And all those quadrants are very similar, just the negative and positive. Last but not least is pink, pi over 3, 2/3 of pi, 4/3 of pi, 5/3 of pi. Alright, now let's focus on the quadrant, okay? Please look at your second quadrant, which is right here. Those are the angles in the second quadrant. All my denominators are 6 and 4 and 3, which is same as the one with 3 did, so that's not new. What do you notice about the rule of the numerator and denominator? So 5, 6, 3, 4, 2, 3. Yes, that's right. So did you know that numerator, I didn't say anything. Denominator minus 1, the numerator 5 is denominator 6 minus 1, and so on. So when you see angle that numerator is 1 bit smaller than denominator, one of these 3, you should know that's in the second quadrant. What do you notice about the third quadrant angle? Once again, all your angles have denominator of 3 and 4 and 6. Yep, numerator this time is denominator plus 1. So you add 1, 6 plus 1, 4 plus 1. Which makes sense because you're taking a pi and a little more. So it has to be top heavy. What about the fourth quadrant? 5/3, 7/4, 11/6. That was the hardest one when we were trying to figure out when we did this last class. And that was what? 1 full circle, 2 pi minus 1 over 6. 2 pi minus 1 over 4 pi. 2 pi minus 1 over 3 pi. So what did you notice about the denominator and numerator? Usually in class I'll ask you, and it's a hard question. Now say numerator is what? You double the denominator. Denominator times 2, and then minus 1. So 3 times 2 is 6 minus 1 is 5. 4 times 2 is 8 minus 1. Okay? Alright. Why are we doing quadrant? Because that's going to give me a hint of how to find which quadrant your angle belongs to. Okay? Alright. Flipping back and forth a lot. Bear with me. These notes are a little different than how I did it, so it's a little different. Alright, now So I know you'll start thinking, like, so how do we use a unit circle again? Hold on. Let's go over here and finish it up, and I'm going to have to make another video. Before we can identify all coordinates of the unit circle, this is 3.3 notes, by the way. We need to investigate the sign of each function as we move around the circle, as well as special case of the quadrantal coordinates. So I'm going to use this table right here. So how do you find the sine value? We're looking at the y value of the unit circle. So if I'm looking for the sine on the first quadrant, did you notice it all has a positive y value? So guess what? Sine is going to be positive on the first quadrant. What about the second quadrant? Still positive y. Third quadrant, negative y. So sine is going to be negative. Fourth quadrant, negative. I don't want you to memorize it. It just makes sense. Sine is a y value. What about the cosine? X value. So where do I have positive x? Right here. So positive, positive, the first and the fourth quadrant. Negative, negative, second and the third quadrant. Tangents are tricky. How do you find the tangent? Y over x. Right? Alright, so first quadrant is positive, positive. So if I do y over x, positive over positive, I'm going to get positive. Second quadrant, what is it going to be? Negative x, positive y. So if I do positive divided by negative, I'm going to get negative. Third quadrant, negative and negative. So it's negative divided by negative. Positive. Fourth quadrant, positive and negative. It's like algebra 1. Negative divided by positive is going to be negative. So first and the third, oh, you couldn't see, sorry. First and the third quadrants are both positive tangent value, and second and fourth are both negative. Okay. Alright, where are we? One more, I don't know what's going to come over here now. Alright. I don't think so. Maybe. Alright, so let me teach you how to use this unit circle. Okay, I'm just going to give you an example of which one you're doing. Let's do cosine of a pi together. This example right here, cosine of a pi. And I'm going to use this one right here. Alright, so here is how it works. You're going to find the coordinate of the pi angle on the unit circle. Where is pi? Pi is what? The farthest to the left. Okay? And then knowing that's farthest to the left, I know the coordinate is going to be negative 1, 0. You good so far? Right here, pi is negative 1, 0. And how do you find the cosine value of the unit circle? You're using the x value. So guess what? Cosine of pi is negative 1. Done. That's how it's going to work out. Okay? Let's do a few more. Cosine of 7/6 the pi, 7/4 the pi. First question that I'm asking you. Which quadrant is this in? Which quadrant? Alright, I noticed the numerator is denominator times 2 minus 1. You with me? So it's got to be what? The fourth quadrant. And fourth quadrant is positive x, negative y. Are we good so far? Yes, very good. Now, what is your denominator? Denominator is a 4. So using the finger trick, which finger should I put? Denominator 3, denominator 4, denominator 6. I mean 3. No, denominator 6, 4, 3. I'm sorry, I'm sick. Alright, so the middle finger. Then how many fingers do we have left? 2. Left side is 2, right side is 2. And where does that go? That's going to go in the numerator with the square root over it. So cosine of, 7/4 the pi has a coordinate of square root of 2 over 2, negative square root of 2 over 2. Let's double check it. 7/4 the pi. I got it right. Yay! Now what are we looking for? Cosine. And cosine is the x value of the unit circle. So answer is square root of 2 over 2. So that's how you do it. So do you kind of see that if angle is on the corners, like pi, half the pi, pi. Wow, 0, half the pi, pi. 3, half the pi, 2 pi. They're easy, right? I don't need a finger trick, like pi over 2. I don't need finger trick. It's these 3 right here. Those 3 are the one that you're going to use a finger trick to figure it out. Okay? I'm going to pause this video and then start another one and practice a few more.